for both satellites orbiting planet C, there is stronger gravitational force on A than B because its radius is smaller to the center of planet C. So A has to be traveling faster to maintain orbit and orbital velocity than B. B can travel a lot slower because of the radius here. If the radius is larger, it decreases this by a factor and changes the velocity.
So as a satellite orbits a planet, even though the gravitational pull is still very close to what the planet would be if you were on the surface, the object never hits the surface because it has inertia. So object B, this is a force diagram for it. As it's coming down, its velocity vector is going this way. So its inertia wants it to keep going out, but the acceleration due to gravity makes it turn around the planet.
So there are four things we could possibly solve for: velocity, radius, and mass of the planet, and of course the period. The period is measured in seconds, which is just one revolution around an object. Mass is measured in kilograms. The radius is measured in meters, and velocity is measured in meters per second. So, for example, if we want to solve for period, and we know velocity and radius, we can use this equation.
Okay, so let's say in this scenario that A has a period of 1.2 to the 10th seconds, and the radius from C to A is 5.4 to the 12th meters. So now we can use this equation and calculate velocity. So now plug this into your calculators and see what you get for velocity. Okay, so when we take this equation and plug in the values for radius and time, like we did here, you get 2.83 to the third meters per second. And that's the velocity of the orbiting object A. So now we have this new equation here, which is velocity equals square root of gm over r. You have to remember that the m is the mass of the planet.
So using our calculated velocity and our radius in this equation, find the value of m for the planet. So what you should have done was use this equation like we said to do, because you're all good children. And so you take this number and this number, you put it in the equation, you square both sides, getting rid of the radical symbol, and coming up with some number. And we skipped a step, and we just multiplied this number times this answer, the answer of this number, and we got this number, 4.32 times 10 to the 19th. Then we divide both sides by g, because g is a constant. G is equal to 6.67 times 10 to the 11th, negative 11th. And you're left with 6.47 times 10 to the 29th kilograms, and that is the mass of the planet.
Einstein developed a theory about space.
It was about time, too.